So now we have a pipe, an open pipe here. In the pipe there is air, a air column. We want to play sound out of it. We will blow on the edge. There. What will happen? A little portion of the air will enter the pipe. Entering the pipe, it will compress. We talk about compression. It will compress the air that is inside the pipe and doesn't want to move. This air is as lazy as the lazy young kid that doesn't want to go to school, even lazier, don't want to move at all. And so that's why we can actually put that in vibration, because if we wanted to move, we blow, the hair goes away, that's it. No. I want to stay here, I don't want to go to school. Okay. And by staying there, it's going to be compressed. That will create a tension. And we observe, also many people did a lot of studies in pipes and things. We observe that we obtain the maximum compression at the middle of the pipe. While it's totally under pressure, it acts like a cork. It's like it's closing the pipe. Doesn't want to have any more air getting in. And the air we blow on the edge is going up there then. So, 1, we blow in. 2, we obtain maximum pressure. 3, it's closed. What happened next? Next, this tension will release. And will release in both directions. Will release in that direction and will release in that direction. So from a tension that's created here, we have release in both directions. Actually in every direction. But where it's closed, it can't liberate itself, which it will liberate itself. So we name it a belly, an open, a relaxed point in the air column. That's always a belly at the open end of a pipe. And this is, you name that nœud in French, you see, I don't remember the name for that in English. Someone does know that? Rod? Okay. Okay, we observed that. What we observed also, we put air here with a certain pressure. What would happen if we put more pressure? If we put more pressure, we will bring this point till here. And it will divide itself like this, exactly like in the strings. It looks a little differently because we had like the nuts at the hand with the string and the belly in the middle, and here it's just the opposite. But that's exactly what happened. And also the division is in entire multiples. So actually what is a wave in the pipe is 1/2 and two halves superposed. So actually we are here 2 half wave. So in this case, what do we have? 1, 2, 3, 4 half wave. I put it so you'll see why. And it's the double. If we have a length of pipe that may produce a C, we'll have a C2 here. And we have exactly the same progression as we have with the string. So now we have a particular pipe. We will consider that, which is a closed pipe. And what we observed always at the open end of any pipe we have a belly, and at the bottom of any closed pipe, any closed part, we have a nut. So what will happen? We blow on the edge, air will enter and compress to its maximum here. I just put it back here. Okay. So how does the wave develop? Phase 1 goes to maximum tension here. Phase 2 release in only one direction, going back to the embouchure, not going further because it's closed. So you have one half wave and a second half wave to complete the wave. So here you have two half waves. But what we see compared to that, what is the main difference? Is the length. Is that the same length? Here we have one half and two half. So total length is that. But here we have one half and second half only superposed of the double of the length.
That's an overtone?
No. That's still the fundamental. We are not in the overtones. No, that's still the fundamental. So what happens there is that a closed pipe produced a fundamental of the double length of frequency. Has anybody a flute edge on with him? Yes? Okay, thank you. Okay, so that's an open pipe, it's open there and there. Now if I use it as a closed pipe like this, goes down for one octave, because we double the length. By changing the way the waves will be produced inside the pipe. More or less. Okay. This is a conical shape and things, a lot of influence, so it's not exactly a real octave, but it's close to be an octave. So, also we can see open pipe if I put more pressure. More pressure, divide by 2 the length of wave. I double the frequency, I'm 1 octave higher. Going down, closed pipe, 1 octave lower. So that's why the little clarinet produced the range of the alto saxophone. If you would have a straight alto, it's the double length of the clarinet. Because the clarinet is a closed instrument, and someone will tell me, why is the saxophone an open pipe? Because it still has a mouthpiece and only open on one hand. It's about the conical shape, but we'll see that a little further. So that's a very enormous difference as this thing. So all closed pipes produce the double length waves for the same length of pipe. So now what will happen with the harmonics? Actually, that's a rare thing. If we put more pressure, we will divide it. And what will happen? We create a nut here. And that will make this. So, one nut here and one belly here. What do we have here? We have 1, 2, 3, 4, 5, 6 half wave. If we have frequency, 1 frequency, here we have 3 frequency. What is missing? No octave comes from a closed pipe. What comes 3 times the frequency, as we have seen in the scale. It's major, and it's a quint above the octave, so it's 12. So this produces the harmonics of a closed pipes are fundamental, quint. Actually, in the scale of the sound, we had 1, 2, 3, 4, 5, 6, 7, 8, 9. Doesn't produce this, doesn't produce that, doesn't produce this. Only produce the impaired sounds. It's not exactly true because we don't have instrument that totally functions as closed instrument, because it's always some part are open. As we can see, it's always in between. If you do that, I close the embouchure, I lower the pitch. So we can see if it's partially closed, it makes a longer waves. So it will change the place. Like in the open pipe, we say theoretically, this knot is in the middle. Why, you know, if you change, you close it partially, let's say like this, you will bring it a little here and create another one. You will move those elements. I don't know myself if someone yet developed an exact theory about those things. That's why developing instrument is very about trial and error, and it's still the case for, according to my opinion, every company. If they say they have a theory, I think they are suspicious.
Just for the translation thing, I think when you're saying not, we're all really thinking node.
Node, yeah, I think so, yeah. Node. I thought it was, okay, yeah, thank you. Okay, so, but we see that has a lot of influence. Also, on the distribution of the harmonics, if we have a partially closed pipe, more or less, it will affect the proportion in harmonics also of the amplitude of the different overtones. So by just changing dimension of tone holes, of course we have seen if it's more closed, it will lower the frequency. So if you put on a pipe, a saxophone, let's say, I decide that the G tone hole, I reduce the diameter, what will happen? This note is going to go down, be too flat. I want to raise the pitch, it's not difficult, I bring it upper. But then what will happen? The distribution of the harmonics will be different, because in proportion you will have with this closer tone hole, and that's paradoxal because everybody thinks that if it's smaller it should sound sharper, but no, it will bring more of the lower harmonics. But also it will be less open sound. It's going to be like a dark, more inner sound that has a little of this mysterious sound, like the clarinet has, or like the pipe. You see the pan flute? That's pan flute. That is some sound because some harmonics are missing, and there are some particular mixture of harmonics, and your ear is attracted for what it doesn't hear. So it gives a lot of different colors, like, you know, different players, they have different way of just positioning the lips and closing and it will totally change the sound quality of the whole thing. So if you play someone, if you close a little bit, it's going to be a more mellow, softer tone. And okay, if it's too low, you can push the hedge on a little deeper. Or like this is more like sunny, brighting sound. So all those things we can do, and I would say that my main approach is to make those things flexible enough that everybody can develop his own approach on one instrument. Because you can say this instrument is out of tune. Every wind instrument is out of tune. What does that mean, being in tune? You know? But you have to make the pitch as much as you have to make the sound. So what I used to say is that the sound is you, and the tools you need to develop your sound is the tool with which you can feel comfortable to, that will react to what you are demanding. So, is that clear enough for everybody? Okay.